welcome you all to this NPTEL online course on Smart Grid. And after a long journey, we are shortly reaching to the last lecture on conclusion. All my viewers, my personal suggestion is to not limit yourself to the course content which has been addressed during last 39 lectures, though they are the basic materials for Smart Grid, but it is a vast research area where you are expected to also look for different opportunities and scope of learning through other sources of literatures and other web media materials. But as a whole, we tried our level best to cover the syllabus on Smart Grid. The main emphasis was just to make sure that you understand both fundamentals and the implementation aspect of Smart Grid. And our experience is limited to the lab scale test bed available in this campus. And I hope for the new learners this is quite enough to understand the basic fundamentals on Smart Grid and bit of application scope. We started with introducing Smart Grid in detail, covering all the architectures, the way it has been described in different literatures, the different definitions of Smart Grid at large. And then we moved to different case studies, the different control schemes, protection schemes, and slowly we entered to different analysis schemes, and we understood what is AC Smart Grid, what is DC Smart Grid, what is AC-DC Smart Grid or hybrid Smart Grid. So, for all three, AC Smart Grid, DC Smart Grid and hybrid Smart Grid, different simulations, modeling and analysis have been discussed. And at the end, I also wish we have to look for opportunity what currently our country is focusing on Smart Grid at this stage, and what kind of initiatives government has taken to encourage young researchers to work in this field, and what are the other avenues available for you youngsters to go ahead for research opportunity in this particular field. Now, if you see India's journey in the field of Smart Grid is quite significant, and if you see today the Smart Grid objectives of India highlights many goals or desired milestones have been fixed. 35 million smart meters installation by 2019, which is a huge target being fixed. Industry collaboration with ESCO model, which is a very new initiative where energy efficiency schemes are adopted by the distribution utilities. 3 full-scale projects on Smart Grid executed with by spending 258 crores by now, 40,000 megawatt rooftop PV expected by 2022, effective use of existing sources, proliferation of electric vehicles, they are coming in a big way. Smart Grid and smart cities are the hot topics, and with this fundamental, certainly I do see that you are learning the course on Smart Grid under this NPTEL online program, not limit you just as a course, but you can perhaps extend your understanding and be part of this Smart Grid initiative taken by Indian government. Now, the government of India approved Smart Grid pilot projects. There are many. The primary goal of the pilot project is to incorporate distribution system with advanced metering infrastructure, AMI schemes, power quality management, PQMs, outage management systems, peak load management, distributed generators. So, you can see there are so many pilot projects are being executed. Most of them have been over and some of them are still in progress. So, we could see that the different pilot projects in the field of Smart Grid are on way at this stage. Now, the worth is too many, the pilot project cost too much, like 3,816 million rupees have been spent to achieve Smart Grid outlook through these pilot projects. And there are few pilot projects under NSGM, National Smart Grid Mission, which has also spent 5,773 million rupees at both Chandigarh, Amravati, Congress Nagar, and at Kanpur. The projects are in process. And currently almost all the leading institutions in the country, all the IITs and most of the central funded institutions today do work rigorously in the field of smart grid. And to mention few, the Indian government has sponsored 5 Indo-UK collaborative projects on smart grid. The first one is Accept HAPAD, Rescue, IMES, and Reconfigurable Distribution Networks led by different IITs. And one of the projects, that is HAPAD, is being led by Indian Institute of Technology, Roorkee. And all the analysis that I have shared with you is the outcome of the HAPAD project and the support that we have received from the Government of India, Department of Science and Technology. Now, there is one more Puducherry Smart Grid pilot project jointly developed by Power Grid and Puducherry Electricity Department. They had very specific objectives, and the implemented functionalities do have advanced metering infrastructure, demand side management and demand response, outage management system, renewable energy integration through net metering, solar electric vehicle charging stations, and street light automation. And this is also quite expansive project at recent time. Now, Chamundeshwari Electric Supply Corporation, Mysore, also achieved a good initiative in the field of smart grid, where the accomplished objectives were 18,076 single phase meters to be installed, installation of 446 DCUs, installation of 3-phase LT-CT GPRS meters, agricultural DSM with community portal, KPI based MIS and data analytics. And this is also a quite successful project at this point of time to highlight the Chamundeshwari project. Then perhaps IIT Kanpur also initiated a smart grid project under Smart City. So they have perhaps actually tried to SCADA implementation of substation through RTUs, rooftop solar installations, storage supported grid connected hybrid inverters, and control room development for monitoring. So they have taken a 20 households and tried to execute a kind of what kind of smart grid concept can be extended so that energy efficiency can be achieved. Now, key smart grid facts and figures till 2016, the number of smart meters were 5.2 million and number of electric vehicle registers were close to 6,000. And there are 4 substations which are completely automated, and now many substations are coming up in this direction. Now, I mean, for all the viewers, I wish to also highlight, after learning this fundamental, this is something I shared regarding the kind of opportunities available for you to participate in smart grid activity at different levels from the government side. And also we have identified few research areas that one can choose to continue the smart grid research further. In the line of operation, control and protection, we have different categories which has been highlighted with the support of many experts across the country. Operation and control of large, medium, small scale renewable energy sources, protection technologies for AC and DC smart grids, wide area monitoring, protection and control, energy management techniques, supervisory control of network with multiple micro and nano grids, network analysis and optimal power flow, modeling and simulation of large power grids, seamless grid operation involving TSO and DSO, forecasting of renewable energy and loads, And there is one more important aspect, that is cyber security and ICT, reliable wired and wireless communication technologies, interoperability and ICT architecture, audit and validation tools for cyber security feature, HAN, WAN and Internet of Things, threat models and cyber security, information privacy and handling challenges, cloud computing, data storage and big data analytics. Now, if you move to the device side, what sort of power electronics area one can choose? Fault right through enhancement of converter interface to renewable energy sources, grid interfacing and islanding issues along with seamless transfer technology, ancillary services of converters, optimal design of flexible power converters, coordination and control of multiple converters and modular multi-level converters, converter technology for HVDC and medium voltage DC systems. Multifunctional hardware smart grid enablers, smart and unified control of converters, hot swappable converters for smart grid, standardization of voltage and power levels, network voltage regulation and power quality, wide band gap devices, and finally we come to energy resources storage and deployment issues, policy, regulatory and market design issues, demand side management with optimization and forecasting techniques for storage and renewable energy sources, inertial issues of renewable energy sources with stochastic behavior, optimal mix, siting and sizing of energy storage at various level of the network, electric vehicle interfacing issues for V2G, G2V and V2H, energy storage system for meeting transient and other requirements, and there are so many industries who are currently working on smart grid. So, you can also choose a future with industry, and to name few, ABB, Accenture, Capgemini, Cisco, Kyan, HCL, NDPL, General Electric, E-Meter, Elster, IBM, Infosys, KEMA, Siemens, Schneider, Mahindra, Power Grid, POSOCO. I mean, there are so many currently focusing on the field of smart grid research. So, I do see a long way for viewers to go ahead if you are taking this course seriously. To conclude the session, I wish to highlight that all the aspects starting from simulation, modeling, theory and understanding and execution of smart grid have been covered in detail. Perhaps we have taken a high level attempt to make you understand the real time simulation of smart grid, and few cases have been discussed in detail. To start with, we have initiated the architecture of smart grid, definition of smart grid, modeling and simulation of smart grid, analysis of smart grid at all three levels of AC smart grid, DC smart grid and hybrid smart grid, and to end up with their applications, we have considered different case studies like demand management, demand side management, demand response, load flow analysis, coordinated voltage control schemes through both hardware and RTDS simulation platform. We have analyzed all the case studies for your benefit, and to make a better understanding of your theory, we tried our level best to cover the syllabi as maximum as possible. Hope this course will certainly help you to make you understand the background, concept and application on smart grid at large. Thank you very much.